Hi, I am Basanta Pathak, a medical student and statistician. Welcome to Handy Research. This is the practical guide to research where we build research thinking from the very best foundation. In earlier episodes, we learned that confounding distorts association. DAG help us to visualize causal structure and the adjustment attempts to restore extensibility. Today we discuss something more important because sometimes the problem is not imbalance. Sometimes the problem is how the data entered in your dataset, and that is called selection bias. And that selection bias, regression alone cannot fix it. So let's begin. What is selection bias? Selection bias occurs during the study, follow up, or analysis, depends on exposure outcome. In simple words, the association is distorted because of who entered or remained in the dataset. This is not about confounders, this is about conditioning on the wrong variable. The core concept is behind the collider. Like, first we understand one thing clearly. What is collider? Collider is a variable that has two arrows, let's suppose exposure or the outcome, pointing into it. A collider naturally blocks the association between exposure and the outcome, or let's suppose A and B variable. But when we condition on C, we open the path. What does conditioning mean? Conditioning means restricting to a specific value, adjusting for it in regression, selecting only certain individuals, and stratifying by it. It doesn't mean deleting it. It means fixing its value in the analysis. For example, if we analyze only hospitalized patients, then we conditioning on hospitalization. Let's understand the fundamental selection bias structure. Exposure lead to selection and outcome also lead to selection, then selection is the collider. If we analyze only selected individual, we open a non-causal path between exposure and the outcome, and that creates the distortion. Here is the simple example. Let's imagine a scholarship program. Students are selected if they have higher academic grades or sports ability. So grade and sports may be unrelated in the general population, but among scholarship winners, if someone has low grades, they must have strong sports ability to get that scholarship program. Inside the selected group, grades and sports become associated. Selection created the association, and this is the mechanism of the selection bias. Now let's go through the Berkson bias, that is the recruitment selection bias. In medicine, smoking lead to lung cancer, the famous example. We always use this, but we select both cases and controls from hospitalized patients. Hospitalization depends on smoking also lead to the hospitalization. Other diseases also lead to the hospitalization, and lung cancer also lead to the hospitalization. Here the hospitalization is the collider. If we analyze only hospitalized patient, we condition on hospitalization. We open a path between smoking and other diseases. This may distort the smoking lung cancer association, and this is the Berkson bias. Hospital based control may not represent the source population. That is the key conclusion of this Berkson bias. Now there is another bias, that is attrition bias. It occurs during follow up. In cohort studies, people are followed over time. Some participants drop out. If dropout depends on both exposure and outcome risks, selection bias occurs. Drug lead to the dropout. Otherwise, disease severity also lead to the dropout. Suppose dropout depends on side effect and health status, and sicker patients on the drug eventually drop out. So we only analyze the healthier patient that remain in the study, and we condition on remain in study that open the path that lead to drug mortality association becomes distorted. This is the attrition bias. So here is the key conclusion, that loss to follow up is not just a smaller sample size, it is the comparability problem. Do you know how to prevent that attrition bias? We always know there is two stages, that is design stage and analysis stage. We have already explained this in our previous lecture. In design stage we can do minimize loss to follow up, use equal follow up procedure in all groups, record reasons for dropout, maintain regular contact. While in analytical stage, compare retained versus lost participants, report missingness clearly, use inverse probability weighting, perform sensitivity analysis. But remember, prevention is always better than correction, so better to do at the design stage. Now, in selection bias, there is also possibility during analysis. Researchers often analyze only complete cases, but suppose missing data depends on disease severity. Now your analytical sample excludes sicker patients, the exposure outcome association changes. Complete case analysis can introduce selection bias if missingness is not random. There is also possible for selection bias when we condition on post-exposure variable that we already explained in the structure. Uh, let's suppose there is one drug treatment and that lead to the ICU admission, and there is the severity of the health status that also lead to the ICU admission. So if you restrict analysis to ICU patients only, you condition on ICU admission, and here the ICU admission becomes a collider and treatment becomes associated with severity artificially. So you distorted the treatment effect. That is the selection bias through conditioning on post exposure variable. Selection in meta analysis. Selection bias also occur at the literature level. Studies with significant results are more likely to publish, and publication depends on study results, statistical significance. If you analyze only published studies, you condition on publication, and that is the selection bias in the evidence synthesis. In conclusion, let's understand confounding versus selection bias. Confounding leads to the exposure and confounding leads to the outcome. It is imbalance between groups. While in selection bias, exposure leads to the selection and the outcome lead to the selection, then conditioning on the collider lead to selection bias. Confounding often can be adjusted, but selection bias often cannot be fully corrected. Design matters more. A conceptual summary for selection bias is it always occurs when inclusion into the dataset depends on exposure, outcome, or both. It operates through collider conditioning and it can happen at recruitment, follow up, analysis, publication, and regression cannot always fix it. Remember this line, the regression cannot always fix. A conceptual summary for selection bias is it always occurs when inclusion into the dataset depends on exposure, outcome, or both. It operates through collider conditioning and it can happen at recruitment, follow up, analysis, publication, and regression cannot always fix it. Remember this line, the regression cannot always fix it. Understanding the data generating process is very essential. Understanding selection bias changes you how to read the observational studies. It teaches you to the question the sample, not just the statistics. If you want structural level research education, follow handy research. This is the practical guide to research and we are building it step by step. See you in the next episode.